This is how easy it is in Linux to use advanced commands in order to control and manipulate strings and file patterns. Also, we are going to have a look at how to create archives, decompress files, and even how to use search patterns to find files based on name or even on size. Stay tuned for what comes next. Thank you for joining Unicast-Administrators. I hope this helps you. So, we will start to talk about our first command, which is file. The file command is a Linux utility that determines the type of a file or of a given object. So it will tell us what exactly are we currently looking at. So if, for example, I type on ls-l, we see that, for example, in our current directory, we have a simple file or some directories as well. And we already know that because we discussed about this on our last video clip. So if we look to the left of the file Anaconda, we can see that we have a dash or a minus, which represents that this is a simple file. And for everything else, we can see that these are directories because they have a lowercase d, which stands for directory. But if we are not sure about that, or if we want to check what exactly this file is, for example, we can type in the word file and we can type in the name of the file as well. So in our case, it will be Anaconda, and it will tell us that this is a simple ASCII text file. And we can even see what's inside Anaconda if, for example, we type in cat Anaconda. And we also can see what exactly are these things that we see here in the color blue, which basically are directories. So for example, if I want to test what the directory downloads is, I type in the command file and it will tell me that downloads, it's basically a directory. And for example, if I list one binary file, so let's go in sbin sshd, we can see that this is a binary file and it's also executable because it has the color green. And to the left we see that this has a dash or a minus. Well, this isn't really a simple file. If we do if we run the command file on /usr sbin and sshd, we can see that this is actually an executable and that it's also dynamically linked. So basically this is actually a binary file, an executable file used by the systemd to start the SSHD service, which is allowing us to SSH on this server. So this is what the file command does. The next commands that I would like to discuss about are called GZIP and GUNZIP, and these are doing exactly what the name implies. So GZIP and GUNZIP, both of them are a Linux utility command that are used to compress or decompress files and or directories. And usually this command has been used and is being used when, for example, you want to preserve some logs on the operating system, but at the same time you don't want them to take up too much space from your operating system. So for example, if I would be to go into the directory varlog, which it's the location where the operating system records all bunch of logs from the operating system, and if, for example, I do an ls for long listing and I do lowercase l, uppercase s, lowercase h and r, which stands for capital S, it's for size, H is for human readable, and R is for recursive rewarder. So basically this will sort everything based on the file size, and it will also sort them in a human readable way, so I can also see the size in human readable values as well. So let's get back to our discussion about the commands gzip. If, for example, I would want to compress this file messages-2024-04-28, which is the log from yesterday, if I would like to compress this file, I'm just gonna type in the command gzip and I would just give it the name of the file, in this case since I copied it, I can just paste it here. This would compress the file, and if I sort again based on size, human readable, and rewarder, we can see that this file now from 1.2 megabytes now has only 202 kilobytes. So we preserved the file, but at the same time we compressed it. We see that it turned red on this line, and it also added automatically a .gz for file format naming convention. So basically this just implies that this now it's archived file. For example, if I would use the command file that we just discussed about earlier, and I would give it to messages with the .jz extension, I would see that it tells me that this is a GZIP compressed data, and it also shows me when it was last modified. So that's what GZIP does. It creates a compressed copy of the existing file, gives it a name .gz, and it automatically wipes the original file. So if we were to list everything that starts with messages, for example, we would see that we have only the log from today, which it still currently writes data to, and we only have the one that we just compressed earlier. So GZIP creates a compressed file, and it shrinks the data. If I do again ls/shr, we can see the actual values as well. So in order to uncompress the file, let's say that we want to uncompress this file for different reasons, I would just copy paste the name, or you can use tab completion. So you just type in MES, press tab, and there you go. GZIP automatically detected the fact that we are going to use this command on a compressed file. It did not automatically take messages, simple messages. It actually took messages with the date from yesterday and with the format GZIP. So once I run this, actually let me also do GZIP -v for verbose, so we can also see some output to our screen. Let me press Ctrl and L to clear the screen as well, so we can see this better. And there you go. The .jz compressed file has been replaced, and now it returned it to its original naming convention. And if, for example, we do again ls/shr, and let's say that we want to search only for messages, we add a star there to take everything that comes after messages, we will see two files. So if before we uncompressed the file we had only 202 kilobytes, now after we decompressed the file we have 1.3 megabytes again for messages file. So this is what GZIP and GUNZIP commands do in Linux. The next Linux utility that I would like to talk about is the tar utility, the tar command. This is a command used in Linux to create archives of files or directories that you would later on want to take out from your system and place them in a different location, or just keep a archive of your data on the local system. So this is what tar does, and let's pick as an example the same varlog messages file that we played with around earlier. So in order to create an archive of the messages file, you would have to type in the command tar -cvf, and C stands for create, V is for verbose, so that we can have an output on our screen, and F stands for force, create the archive forcefully. And the format here it's a bit different. First of all, we have to give the name of how we want the archive to be named. So let's say that I would like to create my archive as archive1.tar. You are not forced to give this naming convention .tar. It's definitely recommended because it makes it easier for you to identify what sort of file this is, but you can create an archive file without putting the .tar as well. So that's up to you. So let's give the destination file what file we want to create the archive for. So the command is tar space dash cvf, give it a name, and then the actual file or directory that you want to create the file for. And it's telling us that it has created the archive. But let me show you an interesting thing though. Pay attention here to the archive that we created, which it's containing messages dash and the date from yesterday, 2024-04-28. It has the same size. So this has not decreased our size at all. Before we proceed with showing how we can create a compressed archive that would actually decrease the size of your file or directory as well, first of all, let's have a look at how you can view the tar archive. So in order for you to view what you actually have inside archive1.tar, you can use the command tar -tvf. T stands for basically just reading the contents of archive1 without actually extracting anything from it. So let's just say that we want to check what we have inside archive1.tar. So we run this command and it shows us what we have inside the tar archive, and we can see the same information as we see here. So it copies the permissions, the inode, which is the one here, user, what user is the owner, what group is the owner of this file, the size, the date, and the action name. So we have all of this here. So this is one archive. Let me show you how you can create the same archive. Let's call this one archive2, but this time let's not give it the .tar format, and let's pick the same messages file as our example. So we have just created one. Let me sort by size as well. So here you can see that this does not have the .tar as well. So if I do a file on archive2, it would tell me that this is a POSIX tar archive. So this is indeed an archive. But look what happens if you give it the name .tar. Not only that it's easier to identify it, but our shell also picks automatically the color for this. So again, you are not obligated to create archives with .tar extension, but it's highly recommended. So if, for example, I want to create an actual archive and compress it at the same time to also not take too much space, in that case you will have to use a command that is similar to the one that we used before, but we add the additional parameter to that one. So let's type in the command tar -c for create, this time z to create a zip archive, v for verbose, f for force, and let's give it a name archive3.tar.jz. Now again, we are creating a compressed archive. You are not forced to give it a .jz file extension, but it's highly recommended because it's easier to identify it. And let's say that we actually this time want to create a complete archive of all the three files. So we would take messages 2024, archive2, and archive1.tar. So I'm gonna create archive3 will contain all three files that I have just given to it. And there we go, we have just created that. Let's sort again by size, human readable, and reverse. And here we have archive3.tar.jz, which has only 604 kilobytes, but it contains the last three files that we see here. The normal file messages, the archive2 that does not have a .tar file extension, and archive1.tar, which is basically one and the same as this one. So archive3 contains everything. It has less size because we used the command tar.c Z, and Z stands for GZIP to compress it as well. And let's view the content of archive3. So in order to view the content, we just type in tar-tvf, and let's give it the name archive3, and here we have the content of archive3. Now let's say that I am going to remove archive2, archive1, and messages.2024 because I don't want them to be here anymore. And if I do a sort again based on size and time, we see that my bad, I forgot to remove archive1.tar. Let's also remove that one. And if we sort again, we have only archive3. So let's say that we want to recover this content of the archive3 file because someone has actually deleted it and we want to restore that data. Well, in order to extract this, you use the command tar again, and this time you start with the X letter for extract, you add the Z for zip because we also want to unzip the file and extract it at the same time, and since this is a archive with the .gz extension, it means that it's also compressed. So we want to extract, decompress the file. We add V for verbose because we also want to have an output on our screen that shows us what is happening. We add an F for force just to make sure that we don't have any errors. And let's say that we don't want to extract the file in the same directory, which is varlog. We will extract it somewhere else. So we extract the archive itself and we add a capital C minus capital C to change the directory where we want to extract this. And let's just say that we want to extract it to the temp directory. I say that that's pretty enough to extract it there. So we hit enter and we have just extracted the contents of this archive, which we still have here. We still have it in varlog, but as you can see we don't have that data anymore here. So let's do an ls-ltr on tmp, and we can see that we have extracted messages here inside the tmp directory, and archive2 and archive1 are also here as well. So that's how you use tar to create and to create archives and decompress and extract archives that are compressed as well. The next two commands that I would like to discuss are actually two commands that are file editors by themselves. And before we do that, let's change directory, and since I'm already logged on as root, I'm inside the root directory. Let's do an ls-l here. So we will start talking about NANO, which is a file editor in by itself. So I could use NANO to edit this file, or I could also use NANO to create an empty file here, but at the same time to edit it. And the second one is Vim, and personally I recommend Vim because it's more advanced than NANO, but since both of them are file editors, let's have a quick look at NANO first and then we'll look at Vim. So in order to create a file with NANO or edit an existing one, you can use the command NANO, and let's say that we give this name to our file1. Let's hit enter, and here you see that we are prompted with the editor itself with the new NANO, and to the left bottom of the screen you see that you have like a higher sign. So in order to use that, you have to press the control button and you press the letter that is right here. So G, it's for help, and if we do that, we are prompted with a display page where we can see all of the options that we have inside NANO. So I got here by pressing the control button plus G, so that's how I got here. And for example, if I want to get out of here, I press Control and X, and I'm prompted back to the page itself. So I can simply type in here, here is my first line from my first file, and if I want to save that, I just type in Control and O for write out. And if you look to the bottom left of the page, it's asking me to give it a file name. So it's asking, it's actually telling me file name to write will be file1. If I want to keep it like that, I just press enter and I will exit out of this, or I can just change the name. So I'm just going to leave it as it is and hit enter. And now I just type in Control X to exit, and we are back to our terminal. Now if we do an ls-ltr, let me also press Control and R. So I'm gonna type in Control plus L so I can wipe my output, so I can clear the screen. So let's type in again ls.ltr, and here we have our file. Now I can read the file using the cut command, and we'll discuss about this later on, but I can use cut file1 to see what I have typed in here. So that's how you write files, you write content to files by creating them. Let's pretend that file1 would have already existed here and we just wanted to edit it. Well, in that case we just use nano. Again, we give it the name of the file, so in our case file1. We hit enter, and here we are. And for example, if I would like to edit this, just gonna go to the next line, and let's say that we are adding our second line to this file using nano, and that's how we do it. So in order to save it, we type in Control-O to save file, and then Control X to exit that file again. If I do a cat again on file1, we can see that we have our second line added as well. Of course, there are so many combinations that you can use with this. You can have a more look into the nano itself. For example, if I go again in nano file1 and I type in again, I keep pressing the control button and I just type in capital G for help, which you can see here on the left bottom of our page. So Control G will take me to the help page, where I'm prompted with all of the commands and key combinations that I can use with nano. So pretty much this is what nano is and what it does. If you want to go more in depth into this, you can use that help page and you can find more information about it. I personally don't use nano, that's why I also don't focus too much on it, but if you want to use it, you can use that page. The next file editor that I would like to discuss about, it's called Vim. So there are VI and Vim are one and the same. The only difference is that Vim, it's the improved version of it. So Vim has features like putting some cool color on your text, so you can identify it easier whenever you are using it to create scripts or creating variables and so on. But pretty much it does the same thing as file. So if I would want to create a new file with Vim, I just type in Vim space and the name of the file. So let's give our file the name file in Vim. Let's name it like this, and here I am. Now Vim at first might be a bit complicated, but we are just gonna focus on the most basic stuffs that you can do in Vim to get you started, and we can go in more depth in Vim later on. So for example, you see here that I cannot really do anything inside Vim, although you see I already entered the file. Now Vim works a bit different. If you look here to the left bottom of our screen, you see that it gives us the name of the file, and in brackets it tells us that this is a new file. Well, in order to enter in the edit mode so that you can type commands or to type lines of text or strings or patterns inside your file using Vim, you have to type in the lowercase I for indigo. And as soon as I do that, if you look again to the left bottom of the page, you see that I am in the insert mode. So the insert mode basically allows us to edit the contents of this file. So let's just give this, I don't know, first line. Let's say that this is my first line from the Vim editor. And if you want to save the files, you see that we are still in the insert mode to the left bottom of the Vim editor. Now you have to press escape once, and now we exited the insert mode, but again we still cannot do anything, and we are actually stuck here. The file is not saved now, and it seems that we cannot exit that. So in order for you to be able to write and save the content of this file and exit the Vim editor, you have to type the colon symbol, which are these 2 dots. And if you look to the bottom of the page, as soon as I press the column symbol using shift and the column button from my keyboard, I am prompted with the column symbol. And here you just have to type in W and Q, which stands for write and quit. And to make sure that I don't have any errors, I type in the exclamation mark, and as soon as I hit enter, I exited the file, and it also saved my data. So as soon as I do a cat on file in Vim, I see that here is my output. Now it added an empty line here because while I was in editor I pressed the enter symbol to create a space on purpose. Let's go back and edit this file. So vim file dash in Vim, and let me show you something else. You can also, let's say that maybe you type in something wrong here and you don't want to save this. Well, you can press the U button to undo what you have typed in. But let's say that maybe you made way too many mistakes and you don't know exactly where you left, you don't know where your problem, where the change that you made actually happened, and you don't want to keep pressing the lower U button for undo. So one way that you can safely recover this file is by not actually saving what you have done. And in order to do that, press escape to exit the insert button. So now I'm in the insert button to the left bottom of the page. I press the escape key on my keyboard. I press shift and the column symbol, and instead of writing WQ to save, I just type in Q and the exclamation mark to quit forcefully from this file and to not save the content. And you'll see that as soon as I do this, nothing here, it's actually saved. And if I cut again the file to see the contents of this file, you see that I still have the same output because I did not save anything within this file. And let's go one more time inside this file. Let's edit it again using the editor Vim. So vim and the name of the file, and you'll see that now I am on the beginning of the first line on the letter capital T. If, for example, I would want to create a new line immediately below this line, I just press the lowercase o button, O for Oscar. And as soon as I do that, you'll see that I automatically went inside the insert mode, but now I can directly edit on the second line. So this is me editing once I pressed, let's type in here, lowercase o. So if I go back, I press O again. This time you'll see that I will go automatically beneath where my flashing cursor is. So as soon as I went here on top and I pressed O again, it automatically added a space, and now this is my third entry, well, editing with lowercase o. Now I exited the editor, the insert editor, using escape, and you'll see that so far I have used only the arrow keys to navigate. Well, you can use other letters as well. So for example, the lowercase h would take me to the left, lowercase l would take me to the right side of the cursor, lowercase j would take me to the end, and lowercase j would take me on top, which in our case would be actually to the end of the file, because from the last line it would automatically take me to the last line of the first entry as soon as I press K. Or you just use the arrow keys. It's way simple to use the arrow keys, so don't complicate yourself, use the arrow keys to navigate here. But let me show you something way interesting. If I type in twice the Y button, so Yankee Yankee, I just copied that line. If I press Shift and capital G, I will automatically be taken to the end of the file, end of the lines. And if I press P, here what's happened, I just copied the first line. So if I press P again, this will be automatically copied. So what I have done, let me show you. So let's type in here, press Y twice to copy. So that's what I have done. As soon as I go here, I type in, I press Y twice, and there we go. If I press P again, I am just copying this. Now, if I would like to delete this line, I just go to the beginning of the line and I press DD twice. So Shift G takes you below. Yep. So Shift plus G. Right? Shift G takes you, for example, if I press GG twice, I'm at the beginning of the line of the file. If I use Shift G, it will automatically take me to the end of the file. And GG will take you to the first line. So that's also one thing. And for example, if again I want to delete this line, I just press D twice. So let me go to the end of the file and press here DD will delete the line. If, for example, I would want to delete everything starting from on top, I would go with GG on top to go on top and press, let's say 20 and then D. So what would this do? If I go on top of the page and I type in 20 DD, look what happens. I just deleted 20 lines. Now I'm just gonna press U to undo my changes and get back to this. And for example, if I'd like to see how many lines I have on this file, I press the column symbol, and if you look to the left bottom of the page, we have the column symbol as well. And let's just type in the words set number. As soon as I do that, I see that I have 20 lines as well. So let's just leave this as it is. The only thing that it's really important here is that I takes you into the insert mode, O takes you to the insert mode. Underneath the flashing line. So if, for example, my line is flashing here on this line, I press O, I'm automatically taken here. YY is to copy, DD is to delete, GG takes you to the beginning of the file, Shift plus G takes you to the bottom of the file, and to save you use work and quit. To exit without save, you use Q with exclamation mark. That's all that you need to remember, just this. Don't worry too much about Vim to start with, just focus on this, and this would be more than enough for you to get started editing files in Linux. You can go way much more into Vim, which we will do, but we will do that in a later video. So let's just stop here working with Vim. I think it's more than enough. So let's exit with saving that. So I'm just gonna do a cut in file edited in Vim, and now we have all of our information stored inside there as well. So I think that's more than enough for the Nano and VI editors. The next two commands that I would like to discuss with you about are the cat command, which you have seen that we used a bit earlier, and the other command is grep. Let's start with cat. Cat, it's used to read contents of files, and it also combines and writes a file's content as standard output to the screen. What does that mean? So, for example, if I would like to see what happens inside, or what is stored inside file dash in Vim, I can see that by just typing the command cat and the name of the file, and we are prompted with everything that is inside this file. Now you see that, for example, this contains a lot of information. It might be difficult to search that information, so let's clear our screen. Let's type in again the command cat, and let's look for our file called file in Vim, and let's add a pipe to this command. Now what pipe does is that it will take the output of the first command and it will throw it to our other command. And here we are going to discuss about our second command, grep. Now grep, it's used for searching for strings and patterns inside files or directories. And if you use grep with -i, lowercase I for indigo, this will ignore uppercase and lowercase. So basically that means that if you have words or patterns that start with a lowercase letter, it will bring it up to your screen. Or if you have words or patterns or lines or strings of text that start with all in uppercase or combinations in lower or uppercase, it will bring that result as well. So let's say that we want, for example, to grep for keywords, and let's say that we want to grep for the keyword delete. As soon as I run this command, it will first read the entire content of file in Vim, and with the pipe command it will record that output, and it will bring in our screen to the standard output in our terminal or to the monitor the result of the second command. And our second command is grep -i and just the word delete. So instead of actually seeing what we had previously, we will have only the lines that contain the word delete. And of course you can combine grep with multiple other combinations to show you more in-depth filters, but I think that for the purpose of this exercise and for getting you started learning and using commands in Linux and searching for contents within files, I think we can just stick to grep -i, and you can search by using different words or phrases or combination. Or let's say, for example, that let's say we want to search for will delete, and this is what it does. It will highlight the words will and delete, and it will bring the entire line. And you have noticed that, for example, I added this in brackets, because if I don't add it in brackets, grep won't really know what to do. So you have to englobe this somehow to force the terminal to show you the output for this. Now another option would be -w, which pretty much more or less does the same, but it's a bit more restrictive. I guess it's enough for you to know about grep -i, and whenever you have mastered the output of files, you can just come back here and have a look at the next video clip that we will do, having a more in-depth discussion about what grep does, how you can use grep to globe the output of files and directories and combine it with scripts. So for now, I think this is more than enough. Before we move to our next command, let's have another example of the cat command. So one nice example that I like to do with cat whenever I want to see how many lines I have in a specific file, I, for example, use the command cat, give it the file name. I use a pipe here to take the output of the first command, record it, and throw it to the next command. And in our case, our next command is WC, which stands for word count, and -L stands for show me how many lines practically there are in this file. So, for example, in file-in vim, it shows me that I have 30 files. If I want to double check that, I can use vim, go in the file, and press shift and the colon symbol, and to the left bottom of the page I just type in the words set number, and I see that I have 30 lines. So let me get back out of here, and this is a pretty good example of what cat shows. So cat is not only used to read contents of the files, but you can also use it to combine it with different commands so that you can show more restrictive patterns, or to restrict your information, or to narrow your search and bring that information to your screen, to output terminal. So that's also a nice example where cat is used, where I personally use it as well. Another cool command that we will discuss next, it's the sed command, which basically it's used to search, find, replace or delete lines or patterns within a file. So for example, if we are to take our file that we edited in Vim and we added 30 lines in that file, if for example I do a cat again on this file, and let's say I want to grep that search for the word delete, we see that we have the word delete in lowercase letters. Let's say that we want to change that without actually editing the file. We can do that using the sed command, -I for input mode, and we open single quotes, and we type in the S letter. For switch we put an /, and we type the current or the old word or the old pattern. In our case, our old/current pattern, it's the word delete. So what I'm doing here, I type the command sed to search and replace, or delete in our case, but we will actually replace this word. -I it's for input, S it's for search pattern, and we are going to search for our current word, which is delete, and I actually wanted to change this from how it looks now to the new word delete in uppercase, all in uppercase letters. I put a / and I type in the lowercase g, which basically means that I want the search pattern and the amendment to end here. I don't really remember what G stands for, but hey, that's the way it was created, so don't ask me why they chose to put a G here instead of cancel. And actually we will do a man page on that, and we will discuss about man as well immediately. And once we change that, let's give the file to which we actually want to make this change to. So in our case it will be file-in vim, and this has just finished. Now if I press the arrow key twice and I'm bringing again the same command, look what happens here. So you see, we have changed from the word delete in lowercase letters to capital letters, everything. And one thing that I can enforce here is that if I remove the grep command, so if I remove the -I from the grep command and I use delete, you see I don't find that word or that line that contains this word anymore. If I go with grep in capital letters, now I find it. So this is where I, it's useful. Even if I have something like capital D, lowercase e, capital L, lowercase e, or lowercase capital E, here we go. We can still find that GREP content. Now let's say that I don't want to do that. Maybe I made a mistake. I can simply go back, run the same command, and just change the order. So instead of having delete, let's change this to removed, but all in lower cases. And I just ran that command, and now if I try to search for the delete word, I don't have it anymore. But if I search for the word removed, here it is. So we have just replaced, first we replaced the word delete with this command. So we search for the pattern or the word delete all in lowercase. We put a / here, and we gave the word to which we wanted to change it to, in our case everything in uppercase, and then / and G to end our command, and the name of the file that we wanted to do that. So first time we changed the word delete from lowercase to uppercase, then we changed the uppercase letter delete to the lowercase letters word removed, and that's how you do it. But I do have to say that you have to be extra careful with how you work with sed. Now sed, usually from my experience at least, I have used this where I have huge files, huge scripts that are hundreds of lines long, and I have to replace a word specifically on that script file or that file. Now from my own experience, I have unfortunately made some mistakes with sed, so I have to tell you again, be extra careful when you use sed. It's extremely dangerous. So if you are not careful with sed, you might actually have some really difficult issues from where you cannot recover. And that's one way of working with sed, but there are different ways as well. So for example, if I want to change or to delete one line from our file, so let's say that if I do a cat on file in Vim, we see that, for example, on our first line we have the word "this is my first line" from the Vim editor. Now if I want to remove that line with sed, I just type in sed, and in single quotes I type in the number of the line, in our case the first line. I type also here a lowercase d for delete, and I just give it the file where I want this to happen. So as soon as I do this, it just brought us here, and there we go. We have just removed our first line. So whenever you do a sed to delete the output of a file, the content of a file, you will have an output on your screen, and now you see that we don't have the first line anymore. Oh, and by the way, if you want to delete multiple lines from the file using sed, you can type in, for example, the number of the lines separated by a comma, and you type in the name, the number of the other line followed by the lowercase d for delete, and you just give it the input of your file. So in our case it's file vim. That's how you also delete multiple lines from one file using vim. And this is how the file looks now after we have deleted our lines number 3 and number 12. The next two commands that I want to talk about are called head and tail. Both of them are similar like cat, so they are used to see the output of files, but head, for example, will show you only the first 10 lines from the beginning of the file that you are giving it to read. So if, for example, we take file that we kept using So head and the name of the file will show us only the first 10 lines from the beginning of our file. And tail does the same thing as cat and head. The only difference between head is that tail will show you only the last 10 lines from the ending of the file. So for example, if I use the same file, you'll see that my output differs. And head shows by default, without giving it any parameter, the first 10 lines, and tail shows the last 10 lines. That's what these two commands do. But you can change that. If, for example, you want to see the first 13 lines from the beginning of a file, you can use head minus n and the number of the line that you want to see. And if I do that, you will see that now we have the first 13 lines from the file. So have a look at the output of the first head. So we had only 10 lines, so 1, 2, 3, space, it's also a line, so 4, 5, 6, 7, 8, 9, and 10, because we had 2 empty spaces. This applies as well. So you will see that we have, for example, head minus 13 shows the first 13 lines. So we have 3 here, the fourth, it's just an empty space, but it's still considered a line. So 4, and with other 4 we have 8, 2 empty lines, 10, and here we have the remainder 3 lines. So that's what head does when you give this parameter. The same thing you can also do with tail. So for example, if I want to see, let's say, the last 14 entries from the file, this is what tail does. And you can even do that by decreasing the number of the lines. So if you don't want to see by default 10 lines, you can just say, hey tail, give me just the last 4 lines from the file, and this is what it does. And the same thing you can do with head as well. If, for example, you want to use head to see only the first 3 lines from the beginning of the file, that's it. You just use head space minus n, a number that you want to give, and here it is. We see only the first 3 lines using head and tail. So the next command that I would like to talk to you about, it's called awk. And awk, it's more advanced than head, cat or tail, because it has more advanced features of filtering the output or the results from a file, where you can use them to narrow your search. So basically, awk, it's a Linux utility used to find strings and patterns within a file, and you can manipulate that output to search for only specific things or to narrow your search. And for example, if I am to look within a specific file, which is etc passwd, this is a file containing the list of all user accounts. We will discuss about this later on, but let's pick this file as an example. And if we look at the last line, we see that we have the user Johnny here. Now, because this output is a bit long, let's use grep -i and let's just search for Johnny. And I just made a typo here. It's Johnny with only 1 H. And if I want to filter the output of this file to show me only, let's say, the 4th column, so that would be this, we can simply use something like this with awk. So we use capital F for format, we put the colon there, and inside curly brackets we type in our search pattern or our keyword that we want to look for. So inside our etc passwd file, we will look for Johnny, and once we find Johnny, the user Johnny, we actually want to output only the information from 1 column. So in that case, we will print only the column number 4, let's say. And just pay attention when you put something in curly brackets here. You have to have one space at the beginning and one space at the end. Otherwise the command might give you some unprecedented errors. And oh, I just noticed now. Let me just remove this single quote from there because I wrongfully placed there. So let's also give the output of the command, the destination file from where we want to take our output from. As soon as I hit enter here, you will see that I am prompted with the GUID, which stands for group user ID, which is this line. So from left to right we count 1 axis to the first 1000, which is the user ID. It's the third field, and the fourth field is the number 1000, which stands for the group ID. If I would like to, for example, change that just for the information from the first column, I just change that dollar value from 4 to 1, which stands for value number 1 from the first column. And that's how you can filter and obtain the information that you want only from one column. So have a look at how this looks and how easy it is. Instead of actually having to watch and go through each and every single line until we find Johnny, we have two options. You either cat for specific words using GREP and you take the entire line, and if you want to combine the output from this one, you can use awk, and you can even combine this command with cat by placing another another pipe here. Take your command, just paste it here, paste, and here is our output. And if we don't want to see that from the first column, let's say that we want to see information from let's say the 7th column, here we have it. So you can use multiple combinations, and this is the beauty of Linux, because you can combine multiple commands until you obtain the desired information. But awk, this is what it does. It just searches for patterns, in our case Johnny, and it just outputs that information. Oh, and I almost forgot. If, for example, you want to see only the ending, only the information located at the end of the content of a file, for example, let's pick passwd again. So, for example, if from all of the lines you just want to take what's at the end, in our case here would be bin bash, sbin no login, and again sbin no login, or usr sbin no login. So if you are looking only for this specific information inside your system, you can run awk pretty much similarly the same way we did it, but this time we're gonna run it simply. So awk minus f space colon, we open single quotes, and you add curly brackets, you add 2 spaces so that you have a space at the end and a space at the beginning, and in the middle you just type in print dollar and in capital letters and f, which stands for number and format, and basically it will just take the ending of the lines from the file that you are giving it. So in our case we are going to use again etc passwd, and let's just print this, and let's just force this to give us only the first 10 lines, and that's what we can see. So what happened here is that from inside the file etc passwd that holds the database of all the accounts in Linux, all the local accounts in Linux, we just filtered so that we can see only what's located on the last line at the end of each and every single line from this file. So instead of having the entire line on the first line, we only have what's at the end, bin bash. Same goes for everything else here. Now you might ask, why are we using this, or what exactly is the purpose for this? Well, These are just some simple examples that you can then take and incorporate into your scripts, or whenever you want to search for specific patterns within files and you want to filter the output to show you only specific information from specific columns in the middle or at the beginning or at the end of the file. So pretty much this is the main reason why I showed how I personally use awk. So I hope this helps. So let's move forward to our next command, and our next command is sort, and pretty much it does exactly what it says in the naming. It sorts the output on how you want to change your output from. And in order to properly illustrate the sort command, I think it's a good example to have a look at our available space, or at how many files it's actually consuming the space in our directory. So let's have a look at the root directory. If, for example, I do the command do, which stands for disk usage space minus a for all minus and h for human readable on the /root directory, and let's put a pipe here, and the output of this command, we are going to take it out, put it inside sort, and again that's going to be sorted in human readable and in reverse. And then let's just force that output to show only the let's say 5 files. It will take a bit of time. Actually, that was not the best example. Let's not run it in root, let's just run it in var log, and there we go. So I can even remove the head. This is what this command does. So sort minus h sorts in reverse order the output of the first command, and in our case we are looking for disk usage for all files from varlog, and we are sorting them in a human readable order based on recursive of size. So that would mean that I will see the highest file that has the highest size on top. If I don't like that, I can just simply remove R, and now if I use that command, I have the highest files at the bottom of our page. Now you can sort by number if you want to. So if I do the command like this with sort minus n, it will sort it by number, and you'll see that this might not help you in this case. But for example, if I am going in varlog and I don't actually want to see the disk usage, but I want to see the files, if I use ls minus l, and let's say that I don't want to see a distorted output, let's sort that by number or by name. So now they are sorted somehow by numbers, and it's not sorting them on an alphabetical order, it's sorting them on size. So minus n for number, it's actually the size. And here we might have some discrepancies, but pretty much this is what sort does. The next command that we are going to discuss, it's called the diff command, and this stands for differentiate or difference, and it does what the name implies. And for example, let's see that we want to create 2 files. Let's just use vim test1, and let's enter here, this is test1, and let's use vim again, and let's create the file test2, and let's just say this is test2 for a second time. I don't know, let's say that that's just work, and I even had the spelling there, but let's just leave it as it is. I think it just works. So the diff command does exactly what the name says. It shows you the differences between 2 files, and it compares that and shows you the difference. So in our case, if I show you again the content of test 1, and if I show you the content of test 2, you see that test 2 has one additional line, and it also shows on the first line the letter 2. If I do diff test 1 and test 2, look at the difference. So pretty much this is what it does. So on first column, on the first file, we have this line, and on the second file, on line 1 and line 2, we have 2 additional differences. Now, what happens if, for example, on the same files we have the same information? Well, let's just test it out, shall we? So let's edit the test2 file, let's remove the second line, and let's just write here, this is test 1. And now if I do a differentiate on test 1 and test 2, both of the files have the same information, and I don't have any difference between them. And as you can see here, I don't have any output, and I can check that with test cat on test 1 and test 2, both of the same files. So if you want to see them separate, because I just used both files at the same on the same line and we don't really differentiate between them, you'll see that test 1 has the line this is a test file, and test 2 has the line this is a test 1 as well. That's why the output of the command differentiate from test 1 and test 2 does not show us anything, whilst at the beginning on test 2 we had something different on the first line and also a second line, and that's how this looks. And pretty much this is what the differentiate command does. It's used just to compare two files and show if there are any difference between them. The next two commands that we will discuss are the locate command and the find command. Let's start with locate. So locate, it's actually a Linux command that it's used to search and locate things within a database, and usually the database needs to be updated frequently, otherwise newer files will not be located. But when we think about database, we're actually referring to the database of the file system itself, and that it's done automatically through the cron job or whenever the server boots, so it's done automatically by the operating system. But there might be some cases where the locate file might not give you the information that you are looking for, and at that point you have to manually update the database. But let's start with the locate command and let's show you how you can find a specific file. So if, for example, I try to find the file named messages, I just run the command locate, and as you can see here we have a lot of output, but mainly the file that I was interested in, it's this one from this var log messages. But because locate looks through the entire database of the operating system, it will look and it will show me everything that contains this messages file. So in our case, vmtools sd.vmsg, we can see that it's inside the KO directory, that it's inside the subdirectory messages and so on, and because messages it's here, it will automatically prompt. So let's restrict that. For example, I am inside root, and if I list here, you'll see that I have two test commands. Let's see what happens if I want to change the temp directory, and I look again for one of the test files. So let's say that I want to search for file in Vim from the temp directory. As soon as I hit locate, it does not find it. Now I wonder why, because it should have done it. And if this is the case, we can use update db command to update the database. This will take a bit of time, hopefully not too long, and theoretically we should be able to find our file as soon as we run locate file in Vim. And there we go, exactly as predicted, we have been able to find our file. So you see, locate, it could be useful, but for example, if you work in a corporate environment where, let's say that in your system maybe multiple users are working and they're changing the files, continuously creating new locations, new directories, multiple things, you get the idea. Locate, it's not that smart to do it all of the times. The operating system does do automatically the update DB at some point, but it's not that frequent. So if you don't find the file, just type in update DB, and once you search for your file, you will locate it. So for example, as predicted, our test in Vim file from our root directory has been found here. So in root, we have our file and we found it with locate. But let me show you the find command. Let's discuss about find, not locate. So our second command for searching for files, it's the command find, which pretty much does the same thing as locate. So find, it's also a Linux utility slash a Linux command that is used to find files and directories, and you can give multiple arguments to the find command so that you can narrow your search. So for example, if I want to search for a specific file based on name, I use the command file, I give it the location. In our case, I want to search within root for the file name, and let's say my file was named file in Vim, if I remember correctly, and there we go, we found it. Now if you don't know exactly where to look, you can use directly the slash, which stands for the root tree where everything starts from. This will take a bit more time as well, and we can be even more restrictive with our search using find. So for example, if I want to look inside the root directory for, let's say, a file with the name messages, and I want to be even more restrictive, I can even search only for the type file, so that would automatically ignore directories, and in that case we type -type and F for file. And I can even be more restrictive than that. Let's say that we want to search for sizes, so in that case we can search for files that have a size higher than, let's say, 1 megabyte. Let's see how many will appear, and apparently we don't have one. Let's see if we look in var log. Curious. Let me just list that very quickly. Var log, we actually have one. Oh, I see now. I see I don't have, so I have messages simple that it has only the size 566 kilobytes, and that's way too small. So my pattern search was looking only for messages, only this one, but because the file that I was actually looking for has a dash and the date inside it, I have to add an asterisk here. So if as soon as I run this, there we go. So you see, we have been prompted with the actual file that I was looking for. My mistake is that I forgot that the one that I was looking for, it's the old file that has a dash and the date after it. So that's why I initially did not find it, because I had to put a wildcard here, a star, so that it will automatically take anything that follows after that. And this was actually a good exercise, because this would mean that, for example, if you don't know what to search for, you could just type in, for example, crow. That should prompt us with some files that, let's say, are higher than 500k, and we don't find that. But cron, what do we have? Do we have anything with cron? No, we don't. I think that the file size is way too small. But what I was trying to point out is that, for example, whenever you don't know the exact pattern, you can look for something different. Let's take another example in our case, and let's look inside slash, and let's say that I want to search for, let me see, log. Do we have anything with the size higher than this? Yes, we do, but the only difference is that I had to add one wildcard for star in front of it and one at the end, because I was not aware, I did not know exactly what I'm searching for. So for example, here we have been prompted with some files from the home directory of Johnny, which are some log files. If you want to look only for files with a find command, only for the type, but you don't want to search for the name, and let's say that we want to pick something that is higher than 15 megabytes, let's see what are we being prompted. So we have a lot of files. That's too much. Let's restrict the search only for var, and there we go. So you have different parameters that you can use with the find command. For example, now I looked inside var only for the type file, so directories would be automatically excluded, and I specifically looked for files that have a size higher than 15 megabytes. And if I return to my initial example, you can even look inside specific directories, search for specific names, in our case messages, and I had to add here a wildcard, a star, so that it automatically takes anything that follows after that. And we restricted the search base for type, file, and for size that it's higher than 1 megabyte. And we can see that var log messages with the date from yesterday has a size higher than 1 megabyte. And we can double check that using our command ls -l capital SHR for size, human, readable, and reverse order. Let's type in messages here, and using the wildcard we see that we have two outputs, messages simple and messages with the date from yesterday. That has indeed a size higher than 1 megabyte. It has a size of 1.3 megabyte. So this was the find command, and now the last command that I want to illustrate, which is, I believe that this is one of the most important commands inside Linux, and that command is man, and man stands for manual, and man does exactly what you heard. It's a manual for everything in Linux, for every command. So for example, if I want to see the manual for the find command and look for what this command has to offer so that I can read the manual, I just type in the command man followed by the name of the actual command, in our case find, and here we are prompted with the actual manual page, and we have different examples. You can scroll up until the end. If you press Q, you will exit the manual page. So let's have a look at the copy command, cp man cp, and here we have some examples as well. And if, for example, I want to search for a specific pattern inside the manual page, if you look to the left bottom of the screen, I pressed the / symbol, the slash, and let's say, for example, that I want to search for the word example, and we don't have it. We don't have it. Okay, let's pick find. Let's see if find has some examples. Yes, we do have some examples here. And for example, we have two entries with the word examples. Now, if you press the N button for November, you will be prompted to the next example. So we have some examples here and many more. So here, for example, on the last page of examples, we have some patterns or arguments or specific commands as well. And for example, this command that I'm highlighting now will find us files named core or below the directory tmp and delete them. So we can also use find to look inside temp for files named core with the type file, so just for files, and using the format -print, piping that to xargs, which xargs takes everything that was from this command stored inside print. That will take it further on, split it with the pipe command and save it inside xargs, and then it will just run /bin rm-f, so it will remove that. So as you can see here, we have lots and lots of examples, and if you get to the point where you don't know exactly what to do, here for example we have a command for size that is looking just for size, pretty much similar to the one that we used, but this one it's a bit more advanced. Actually, it actually spreads to the next line as well. So as you can see, you have a lot of combinations that you can use with the find command, and if you don't know what to do, you can read the entire manual for that page using the man command. Or another option is just to run the command with space -- help, and this will show you a pretty much a summary of all of the commands. But if you want to go more in depth with each and every single command, just run man find. So this is pretty much what I wanted to show you today. Again, I have to reinforce the idea that, in my opinion at least, man is the most important command in Linux. If you master man, you master any other command. So if you don't know what to do, just have a look at man and look up what's stored there. So that would wrap it up for today. I would like to thank you for taking the time for watching my video clip and checking out my channel. Even if this took a bit longer, I thought that it's best to do it a bit more explained, and now this was, at least in my opinion, the last common command that we had to review. So moving forward from the next episode, we will start working on actual user accounts, working with the disk partitions, with the logical volume manager, securing our server by modifying the SSH port, and many more. So thank you again for watching. Thank you for the time that you took for checking my account and my channel, and I really look forward to seeing you next time. Cheers!